Okay, welcome back. So thank you for this opportunity for us to go step by step on the usage of the DTA Lite and the Nesta package. So throughout this session, I would like to just go through with you the very detailed operation of this software package. So first of all, let's try to make sure you have downloaded the package, unzip the package into your local hard drive. So for many students, if you do not know, if you have not unzipped the package, if you just execute this executable in the zipped file, you might have some issues. So anyhow, so here is an unzipped folder of our DTA Lite and the Nesta package. Number one, you need to look at the Nesta executable. This is a Nesta.exe. Number two, you need to look at all the detail folders we have. And then number three, here is a DTA Lite.exe. So this .exe is a simulation package. So for most of the users, you might need to just click on this Nesta, and then you should be able to get the software package, and you can run the software package to view the visualization results. Okay. Then along this way, we have prepared a number of data sets for you, and all the detail elements, all the detail documents can be found in this data folder. So as you can see, the most important data elements is the Nesta and the DTA Lite interface plus the white paper. So from here, let's go to the page number 0. Okay, in this white paper, we have the DTA Lite as a queue-based mesoscopic traffic simulator for this fast model evaluation. And by going through these documents, you should be able to understand some further details, simulation details, such as flow, density relationship, backward wave, and the detailed derivation and the simulation logic, simulation procedure along this way. Okay, I defer to the reader's effort for reading these particular documents. Okay, and we also have workshop handout, the learning document for GIS importing. If you have the GIS package, be available to read it, to be imported into our Nesta interface. And then on document 4 and 5, if you want to learn the traffic flow assignment and the equilibrium representation, dynamic OD estimation, how the ABM being connected with the DTA, and you can read the corresponding learning documents. Okay. So for many users, if you have a 32-bit version, you might need to use a 32-bit Nesta interface. Okay, and you can use them as is and to run the simulation package. Okay, since the DTA Lite and the Nesta interface also the DTA Lite and Nesta interface has a parallel computing. So for many users, you need to follow the guideline available in our website to install this Visual C++ registration package so that you can enable this parallel computing running mode. Okay. You have more issues, just go to the website. You should be able to finish the installation and then enable a parallel computing facility used in the Nesta package. This GNU package is a visualization when you try to plot the space and time diagram. Okay. So now I would like to go through the detailed representation of the Nesta package. So if you go to the dataset number 1, you have 2 packages or 2 folders here. Each folder represents a dataset. So here I have the West Jordan baseline, base case, West Jordan agent-based representation. So these represented 2 different scenarios. Go to one dataset, you will see a number of files. So in each dataset, you can try to sort the files into this structure. For all the files begin with input, they are the major input files required by the DTA package, such as input node, input link, and the input demand file list, input demand table. Okay. So if I click on one particular data file, if you have attached the CSV file with the Excel, you should be able to look at the node number, control type, X and Y representation, the corresponding geometry associated with the DTA line and the Nesta interface. Okay, all those files, all those fields is ready for you to make the changes in the Excel and then save it. Okay. Let's look at the input link. In the input link, you have form node and the to node. You have the length, you have the link capacity, the link type, and other elements. So in this input node, input link, at the last column, you always see a geometry field. In this geometry field, you can see those are the detailed line strings, link string coded in some relatively complicated format. Those streams are generated by the Nesta. They are not required in the simulation package. They are really serve as a way for us to visualize those detailed geometry information. Okay. You also have the input zone. The input zone representing the zone ID and the detailed geometry. And you also have the input file list. The input demand file list is the hub for us to connect all the different demand files together to simulate the different agents. So in this particular example, we have one file. This is the input demand file. The data format is colon. So the users can code colon, matrix, full matrix, all the different demand format into this meta database, or this a huge data hub for importing the demand. So typically, since when we try to deal with the demand file, they do not have the clear time-dependent representation. So we need to make sure when you import this matrix is corresponding to a start time in minutes, end time in minutes, and then you can further apply the time-dependent profile every 15 minutes. Okay. In this particular example here, I have this demand corresponding 3:30 p.m. to 6:15 p.m. and then you can try to see this is our demand loading profile. Okay, in this simulation. Okay. So for the users, for using this particular package, I always encourage them to look at the user's guide and then to look at a toy network they can create it. This toy network has a minimal data set of input node, input link, and the input link type. Okay, we will go through those exercises step by step in many cases, and in the following sessions, hopefully you can bear with me and then finish the exercise. Thank you. Let's try to use the Nesta interface with me. So first of all, you can go to the software package, click on the Nesta interface, and then it will show this interface. Okay, so this is a Nesta interface. This is a layer by layer representation, very similar to a GIS software package. Then for you, you might need to go with me step by step. Number one step, go to open a network structure. So recall that we have this software package, we have this data set number one, and we have West Jordan. Let's open the West Jordan case. So then if you go inside this data folder, you will see this a TMP file. So as you recall that we have a number of files inside this folder, but in the Nesta, we only look at this file extension name TMP as a way for us to recognize the data folder. So go ahead to import this data folder. This is open. Okay, so you will see this interface. Use a mouse, use a wheeler. You can zoom in and zoom out. Okay, and use the mouse. You can move to the left and then to the right. We do have this background image. You can go to the Nesta. This is a GIS layer. You can click on the background image, on and off. On the grid, you can on and off to highlight the most important feature. Okay. So let's go to the node layer. Then a node in our representation is an intersection or is a merge or diverge point at a freeway. So if I click on this background image, you can see this node representing a intersection. Okay, this node representing a intersection. Those are the side streets. This is a major intersection. Okay, so for each node, if you want to see the node number clearly, please use this plus and a minus sign. Plus. So if you click on this plus sign multiple times, you should be able to get this node number. Use a minus sign, you can decrease the size of the test display. Okay, and we have node. Then you go to the link layer. On the link layer, you can always make sure you use a click mouse. Here is a click as a selection, and then you make a click. Then the being selected link, the link being selected will turn red to indicate that you have selected this link. Do the right click. So on your mouse, do the right click. When you do the right click, make sure you are on this link layer. So in this GIS layer, if this link is selected, or when you try to use this mouse on the network panel, and then this link layer should be displayed as red, indicating that this layer is selected. So right click on this link, then you can view the link property. So this is a link property including form node, to node, length, the number of left turn lanes, the number of lanes, the link capacity. Okay. So I may ask one student for this very simple question. So if you click on this link, remember, typically the link capacity should be very small, but in this link, we represent this link as a connector, or as a facility for us to reach all the inflow demand into the physical network. Okay, so the lane capacity is quite large. It's 10,000 vehicles per hour per lane. And then let's go to this actual physical lane. Okay, you can view the structure, and then you can see the capacity is a little bit more reasonable. Okay. Okay. So let's go to the zone layer. The zone layer can also, you can have this check on and off to display the zone layer information. For each zone, for example, on this zone, you have zone number 1, and this zone number 1 is attached with the node 5577. If you go to this zone 32, this zone is attached with the node 1285. So basically, for the ODD matrix, the ODD matrix is represented as the zone, origin zone, destination zone information. And then when we try to generate the shortest path throughout the network, we need to assign the vehicles from origin zone to the destination zone. So first of all, we need to do the mapping to find the origin node. So this origin node 1285. And then we can find the corresponding node sequence in the physical network to enable the simulation. Okay. So for this particular feature, when you understand node, link, and the zone, I'm going to ask the users to go with me, go to the project, the menu project. Okay. And then you can go to the number 1 item. We have item as 1, 2, 3, 4, 5, 6, 7. Let's go to the number 1 item. Okay. So you can clearly see we have node, link, and zone, 3 layers. Okay. In the node layer, you can try to click on the node. You can try to get the corresponding information, make some editing or limited editing along this way. You can also, a nice feature here is you can do a zone to the selected object. So if I want to know node number 1285, and then you can see let me just do some illustration here. Exit. Okay. Okay, on this side. Then if I click on this node 1285, if I click on this node 1314, if I click on this zone to the selected nodes, so I can understand, where are the location of each node. Okay, this is a quick way to find the corresponding node. You can also sort the node number. You can also sort their control type. Okay. Another way to find the node information is you can go to the view. You can go to the view. You can go to the editor, and then you can try to do a search. Search the node, link, and the path attribute. So if you have a keyboard, you can use the control key, then plus F, just as we identify here. Control plus F, you can try to search a node number. For example, I search a node number as 1314, as we just displayed, find, and then this node number 1314 is here. Okay. For example, in this case, we have zone number 2 corresponding to 1123. You can use a control F. Okay. Then you can find this 11123, okay, as the node number. Okay. You can have another control F, try to find the link. So you need to select the second element here, find the link. So on the screen, I have this link 5017 space. Okay, any space or how many space, it does not matter. 11146. Okay. Then I will try to find the link. Remember, the link we have here are directional link. So you can have 5017 21146. On this link, I need to go to the link layer. On this link, 1146 to 5017, they are the link on the opposite direction. So on this panel here, you can see the name, Redwood Road, from node ID to node ID, the type, and the speed limit, the freeway, the free flow speed, the number of lanes, the related information along this line. Okay. So if I go to the third layer, as typically I do not display here, is a movement. Okay, this is a movement and the traffic signal light. When we have more opportunity, we will try to explain the representation of the traffic signal lights. Okay. So let's go back to the Control F key. Okay. In the Control F, you can also try to find the path from the from node to the to node. Okay. Let's try to use a small illustration here. Okay. So for example, I would like to go from 1318 then to 8002. Okay, on this path. So I do the Control F. Make sure I select the path. Okay. Then my origin node is 1318. Okay. Empty space. Then 8002. Okay. So what we do here is we enable a shortest path calculation inside the Nesta calculation engine. Then we say find. Then the corresponding path will be displayed. Okay. The user can also go to this path layer. So you can select the layer here as a path layer. You can define the origin. Doing the right click, mouse right click. Define the direction from here. Define the direction to here. So we get a path from A to B. Okay. For the users, if you have a demanding requirement, you can define your destination to here. So every time when you redefine your destination, the path will be recalculated, very similar to Google Map or other map engine. Okay. On this path layer, you can also try to add intermediate destination here. For example, I would like to go this A to B path. I would like to go through this intermediate destination. So by doing so, I force the shortest path calculation. First of all, go through this intermediate destination first. Okay. I can also add another options such as avoid this node or avoid this link. So after avoid this link or avoid this node, and then this path, we'll try to utilize this D2 to access the final destination. You can remove all the other features. Okay, and then you can also view the path data dialog. Okay, now we have so many features. I don't want to discourage you by just show many features in the first time, but you can try to see along this path we have different link, and we have this time-dependent simulation travel time from the simulation package. Okay, so by demonstrating this node, link, and the path layer, I hope you can get a very basic network representation understanding throughout this session. So going back to the zone layer, you can go to the project, you can go to the sensor information. So we have node, link, and a zone. Okay, as we described, we have this node ID 1, in this case 1 to 41. Then we have this particular activity location table. In the file we have is this input activity location. Okay, so this activity location file try to map the traffic management zone ID with a physical node ID. Okay, so to be clear, a zone can be mapped to multiple activity nodes, and an activity node can be shared by multiple zones. So it's a very flexible one-to-many mapping, a very flexible man-to-many mapping. We have movement. You have other type of information such as sensor speed, sensor count. We have more details along this way. Okay, So after you have this node, link, zone information, you can try to see the connector information. You can see the OD demand matrix. So for most of the users, I fully encourage you to look at the demand information directly on the file. So let me go into this data set. I already have input node, input link type. Input link type just for a quick illustration. Different link type for the traffic flow simulation. There's a link type code. F representing freeway simulation. H means highway simulation. A means arterial simulation. R means ramp. C means connector. T means the transit. W means work zone. So we have different link type being coded in this structure. Now we go to the input demand type. In the input demand file list, you can click on the input demand file list one more time. You can go to the file name. This is input demand.csv. The data format is column. So what you do here is open up the input demand file. Okay, in the demand file, this is a column format. So we have form zone ID and a tool zone ID. These are number of trips to be simulated. So look at the second column. From zone 1 to zone 2, we have 30 vehicles being simulated. So traditionally, since they use a fluid-based representation also on the 4-step process, so the number of trips we have to simulate here is 30.36. Okay, 30.36. So what we do in our simulation package, first of all, we read zone 1 to zone 2. Okay, for these 30 vehicles. Then if you're going back to the input file list, the demand file list, we know that the starting time and ending time is mapped to this particular time interval. Okay? And then we have this demand type number 1. We are going to simulate all the demand specified in this matrix as the demand type 1, which is a passenger car. And then we have the corresponding demand loading pattern, okay, as specified in these field columns. Okay, now the task is I need to simulate 30 vehicles from zone 1 to zone 2. Okay, what I should do? So if you go to the input activity location, you need to find the corresponding physical origin and the physical destination nodes. So this is the input activity location. So from zone 1, if you take notes, 5577 is a corresponding physical activity node for zone 1. Zone 2, 11123 is a physical node for the destination node or for the activity node for zone 2. Right? So what we have is, if you go back to the Nesta interface, zone 1 is here. Zone 1 is here. Okay? We have a corresponding 5577 as an activity node. Where are the zone 2? It's relatively difficult to find zone 2, but you can try to find the corresponding node ID. Okay, here we go. This is zone number 2, right? 11123. So in a simulation package, essentially, you can use a Control F, or you can just define as a path from origin to the destination. So you will simulate, you will find the path. Actually, it's not just one path or one shortest path. You have to find multiple paths based on the traffic condition and then simulate them throughout this process. And then this is the way we call this as a traffic simulation. Okay, I would like to go over very quickly. So after the traffic simulation, the results are the output agent. In the file name is output agent. It stored all the details past information. So I would like to just guide you through here. Let's look at the vehicle button. So on this button, we have this in this Nesta interface. We have the button network, animation, density, volume. I would like to guide you through very quickly to the last second button, vehicle path. I can have origin 1, I have origin 2. Okay, so now I'm select origin 1 zone and origin 2, zone 1 to zone 2, right? So let's look at the vehicle information. So we have the baseline. How many vehicles do we simulate? 30, right? Very consistent to our demand file representation. Okay, and then the average travel time is 2.2 minutes. Average distance is 1.5 miles. Average speed. Okay, you can further click on this. You can further click on this vehicle file list, and then you will see we have the vehicle ID 462 starting from this departure time. Take this particular 2 minutes travel through the interface. Okay. So if you want to do a more detailed vehicle specific analysis, you can click on this button, vehicle data analysis. Okay. So now we have the SOV, single occupancy vehicle. We have 30 vehicles. Okay. You can do this analysis every 30 minutes. These are 3:30 to 4 o'clock, 4 o'clock to 4:30. So along these 4 different demand time periods, then you can see eventually we generate the vehicles, 7 vehicles for the first time period, 8, 8, 7. So we simulate this departure pattern along this way. And then in the y-axis, you can look at the average travel time, average travel distance, the average speed. You have a number of statistics along this way to show you can simulate, and also you can process of all the different statistics. So some questions might come in from here. Where are those actual vehicles? Where are the files storing their information? So let's try to go back to the file. So if you're going back to the file, you can try to have the output vehicle or output agent, being displayed here. So if I open up this output chip information, you have agent ID, you have the 2 information, phone zone, 2 zone. So this particular file, output chip or output agent, will store all the detailed information for each agent, for each phone zone, 2 zones, departure time, and then those are the grand set, the total database, the complete database for all those information. For the users who are familiar with Excel operation, you can try to do this filter. Okay, sorry for this Chinese version of Excel. Okay, you can go data, do the filter. Okay, in this filter, I can only select zone number 1. This is zone number 2. Okay, then you can see all those 30 vehicles being displayed here, and that is corresponding departure time, corresponding ending time, and you can calculate the travel time being the ending time minus departure time, and then you can get the detailed information along this way. Okay. In this file, typically, we also need to have this output agent. Okay, output agent, and then this I will leave this as an exercise for the users to click on the DTA.exe to simulate and then produce the output agent. Okay, along this way, this output agent in this particular data set, the file size is 0, means we have not produced the output agent in this process yet. Okay. So the concept I want to convey here is we have a network with origin, destination for the different demand pattern. We have a node and a link structure. we have this demand matrix coded from the zone layer matrix, and then we map them to the physical origin, physical destination, then find the result. The result will be changed based on the traffic condition, and then this is the whole process of traffic simulation. We find the different routes for the different origins, for the different type of agents. We simulate them throughout the process, and then finally we are literally check their statistics. So let me go through this process. Going back here, this is a network, right? This is a network. I can try to show some simulation. If you do not want to see the path, you can click on this path, then to display, to hide the corresponding display. So if you don't want to see the zone, hide it. If you don't want to see the node, you can hide it. Okay, you will then zoom in a little bit to see the animation. So some student might ask me, well, I can see the animation. Remember, the simulation time period we have is 3:30 p.m. to 6 o'clock. So you have to, along this time clock exit here, this is a time clock bar, simulation bar. Before 3, we don't have any vehicle in the network. And then after 3, you can see all the dots being displayed here. All those dots, each dot represents one traveler agent or the driving only vehicle. So if you try to see the background map, you know that. Okay, along this lane, sometimes you have multiple lanes, sometimes you have lane changing or what complicated lane geometry representation. But in this little representation, it is a microscopic simulation. As we discussed before, we only model a link with the multiple lanes. We hide all the dirty details inside the simulation model. We only care about the incoming flow, the outgoing capacity. We use the capacity as a major measurement or the major measure to control the flow dynamics. Okay. So now you can go to the density. This density is the attribute on the link layer. Okay. So to understand the detailed density information, you should go to the link MOE layer. Link MOE layer. Okay. Make sure you have this link MOE layer been selected. Then I need to make sure I have a select object cursor here. Then select this link. So you can one click or double click. Then you get the corresponding link MOE. So what we have here is starting hour 15 hour or 3 p.m. and ending hour as 18 hour, which is 6 p.m. The aggregation time interval is 1 minute. You can do 5 minutes. You can do a 50-minute. Different aggregation time interval will show you the different type of the smooth trajectory. If you want to see more MOEs, you can look at this comprehensive menu. Output volume, input volume, and you can also look at this cumulative arrival and departure. You can look at the density. So in this particular graph, we show the traffic density starting from 3:30 p.m. and then stabilize, still has some fluctuation due to the incoming and outgoing flow trajectory, and then we finish this simulation time interval at 5:30. Okay. You can also try to compare the both measured. This on the top is the density, on the bottom is the speed. Okay. So you can try to convert them. You can try to also show the speed in mile per hour. You can try to show the link-based speed. Okay. And also you can show the queue length. So by doing so, we try to use this link MOE layer to display as much as possible this type of measurement for you. Okay. For the users, if you try to select multiple lanes, I will say multiple links, you can try to see One click, use a control key, control. Okay. Then you can see the opposite or other related links. Okay, and then you can display those information. So since it has so much information in this process, you can always go to data, go to the menu data, then try to explore the link MOE to another Excel file. Okay. Once you have multiple scenarios, you can explore those scenarios, those MOEs into multiple columns, and then the project info here. This is a baseline alternative. Then by doing so, it will enable you to compare and then to see how a close link, how an incident can create the different, different type of impacts. Okay, as a part of the simulation, results, all those MOEs is stored in this output, OD MOE, output link MOE, okay, in those different files. Okay, you can click on those files to see the more details. Okay, okay, back to this dialog. So we have link density. You can also try to see the link volume. Okay, the link volume, the width of the link volume is displayed with the legend here, link volume. You can try to, on this toolbar, on the very first toolbar, you can try to increase the link bandwidth. By increase this link bandwidth, then you can try to proportionally display the link volume according to their underlying traffic, number of vehicles being transported from this time interval. You can try to move the cursor up and down to see how the link volume being displayed. For the user, if you see we have too much fluctuation, you can always go to the link MOE layer. Okay, click on this link, and then remember we have this aggregation time interval. You can use a 30 minutes aggregation time interval, so that when you try to move this cursor, this link layer fluctuation will be smoothed out. So we have link density, we have the link volume. Okay, we can also have the link speed. This link speed is displayed as a percentage of the speed limit. 100%, 80%, 65%, all those speed legend can be configured. All the speed engine legend can be configured according to the percentage of the speed compared to the speed limit. Queues. Okay, I go to the node layer to make sure when I click on the network, I don't have too many response. Do we have any queue here? We do see some queues. So on this background information, you can always to configure. I don't want to show the background image. And here you can see this link volume display. You can always switch back and then go to the network layer, then go back to the queue. Then this is a queue display. So when you click on the network layer, it will only show this straight line representation. Okay, queue. I can see how the queue being modeled in this representation. Then we have some additional statistic being displayed as the impact and the bottleneck. For the bottleneck, you need to make sure you have this node layer being displayed, and then the bottleneck. Okay, this is not totally realistic, but we do have one large bottleneck as the percentage of as proportional to the total waiting time emission. Okay, on this button, you can have the link-based list. On this link-based list, you can have speed limit, lane length, and the speed. You can always try to see which link is the link with the largest volume. So I can say link 101 from node to node. If I use this zone 2 select link, then I can see which link has the largest volume or has the largest delay, depending on what are the statistics you are interested. Okay, this is average density, this is maximum sum density, the waiting time on the queue. So using this structure, using this type of the link-based information, you are able to investigate or explore all the link-based statistics. Okay, you can try to only look at within the sub area, freeway only, highway only, arterial only, connector only, and all the links except the connector. So you have many different flexible configuration, including the starting time and ending time, to calculate the corresponding statistics for this link level comparison. Okay. Then path information, as we described before, the users needs to go to the path layer. Go to the path layer, make sure path is displayed, and then typically on this path layer, we need to go back to the network representation. It's easy for us to manage. I would like to see right click, define origin, define the destination. So along this corridor, what are the travel time? Okay, and you can try to plot the travel time contour along this way, and also you can change the link attribute such as number of lanes, the link type, speed limit. You can make a number of changes to manage these link level statistics. Okay. The vehicle level statistics, this button next to the last, also is a very comprehensive way for you to see the multiple simulation results. So I can define origin, destination for all zones, different demand type, different vehicle type, different information type, and then I can try to sort the OD demand matrix according to their distance. So as I can see, I click on this average distance. The longest OD pair is 21 to 16. Okay, and then I have see this corresponding path they use. Let's try to just show from here. So on the right, I have a sorted list of OD. Okay, then I can see from this origin zone 21 to 16, I have two paths: path 1, path 2, path 1, path 2. Then on each path, they have different number of vehicles, such as 9 vehicles or 2 vehicles, and they have different travel time, and then they have different driving distance. So you can see for this traffic simulation, for different zones, we need to simulate the agents at the different time periods and also along different routes, and then the ending result will be the link volume, link speed, link density. So I'm hoping that by going through these, I'm not going through more details, but going through those link, node, volume, speed, density, vehicle, path, you can get a much better, a very solid understanding about different elements or the different perspective of transportation network modeling. The last display we have is the summary. The last display we have is a summary. So on this summary, as I want to show you, you can sort it along the x-axis, along the y-axis, with also different travel time, and also the spatial axis. You can select the network-wide statistics, the selected OD statistics, select the link statistics, and there's many attributes for you to define the sub area and then make the selection. Okay, and all the data available here, you can always have one click, export all the data into the Excel, and then after this one click, and all those network-wide statistics will be propagated into the Excel for you to make the comparison. Okay, so as we just mentioned a little bit about this sub area, how to define a sub area. What you can do here is go to a sub area, make it close. Okay, you can define another sub area by clicking on this sub area again. Okay, double click, you close the loop, and then once you have the sub area, you can always go to the summary and then go to the sub area and then define a number of statistics for the vehicles originating from the sub area, traveling through the sub area, and all the trips passing through the sub area. Okay, so with this, we almost going through some visualization feature, but we still need to go through one more time using the presentation form. Hopefully you feel comfortable in managing the visualization interface and also the underlying data structure. So for the users who wants to prepare the Nesta or DTA-like package, you should go to the guideline for using the Nesta package. So we have getting start, installation notes, data flow, user interface, GIS importing, and we have a very comprehensive table for you to learn, such as what's a DTA like, what's a TMP file, required software package. I'm hoping that you can track through those items so that you can have a good understanding of all the different learning section, learning material, and to get a good understanding. Good.